So good morning to all the students of class 9th of Cls9th Middle School and all the students worldwide. So we have been going through the chapter gravitation of physics. So today I will be continuing from the part from where I have left. I would again like to say you that all of you please be at home, be safe, stay at home, take care of your parents and the elder ones. And I am Engineer Kumar Harshvardhan, and today I am taking class of physics, the chapter gravitation on behalf of Pride India Central School, Rajdham Mahal School, Khagadiya, one of the best schools. Okay, so now we will move on to our next topic that we have left out. So what is the topic that we have left out? We will learn about the unit of gravitational constant. What is the unit of gravitational constant? The unit of gravitational constant. Unit of gravitational constant. So we have already seen that. What we have seen that, as we already know that, F is nothing but F is equal to G into m1 into m2 divided by r square, where F is the force, G is the mass, F is the force, G is the gravitation, m1 and m2 is the mass of body object 1, mass of object 2 or body 1, body 2, divided by this, r is nothing but distance, so distance square. Okay, so now if I need to find G, what I will have to do, I'll bring it here. So F by G, or I'll do here one thing. Instead of bringing G here, I'll put F there. So this will be equal to, if I take G here, G by F. Okay? Or let me do it like this. F by G is equal to m1 into m2 divided by r square. This implies that F into r square is equal to G into m1 into m2. So this implies that if I take G, G is equal to F into r square divided by m1 into m2. You get it? Very simple to derive. F is equal to G into m1 into m2 divided by r square. I take G here. F by G is equal to m1 into m2 divided by r square. Cross multiplication. Okay, so F into r square is equal to G into m1 into m2. Therefore, G is equal to F into r square divided by m1 into m2. Now, force. What is the SI unit of force? Newton. What is the SI unit of distance? That is meter. But what is this meter square? This r square is nothing but r into r. Therefore, if r is in meters, therefore r square is r into r. This implies that meter into meter. This becomes meter square. So this becomes meter square divided by m1 into m2. Mass in how much? Mass in kgs. Kg into kg. So this becomes Newton meter square per kg square, or also we can write as Newton meter square per kg square, or Newton meter square kg to the power minus 2. If you don't put this slash, you can write this goes up kg to the power of minus 2. So this is what is the unit of gravitational constant. Okay, I think this might be very much clear to you. There might be no problem in this. Okay, so next we will move on to the value of gravitational constant G. This is very much clear. I think there should not be any problem. F is equal to this much. So F by G is this. So this we cross multiply. So G becomes F into r square divided by m1 into m2. This implies force in Newton. SI unit of force. R is nothing but distance. So distance in meter. Therefore distance square meter square divided by mass of m1 is kg. Mass of m2 is kg into kg, kg square. Newton meter square kg square. This you can also write it as Newton square slash kg square. If you don't put this slash, you write to the power of minus 2. I think this might be very much clear to you. So next we will be moving on to the value of gravitational constant G. Value of gravitational constant, that is G. Okay, value of gravitational constant G. Okay, Okay, so let the mass of body m1 and body m2 be 1 kg each. Means this also 1 kg, this also 1 kg, and the distance b by w means between, and the distance between them be 1 meter. M means meter, 1 meter. So we can say that F is nothing but G into M1 into M2 divided by R square. So now what we know? M1 is nothing but 1 kg, M2 is also nothing but 1 kg, M1 is M1 kg, M2 is 1 kg, R is nothing but 1 meter. Okay, so putting all these values here, F is equal to G into 1 divided by 1. So this is nothing but F is equal to G. You get it? F is equal to G. Okay? So F is equal to G. Let the mass of body M1 be 1 kg, mass of body M2 be 1 kg, and at a distance between them is 1 meter. Okay, this you can write it here, close by 1 meter. So we can say that F is equal to G into M1 into M2 by R square. M1 is 1, M2 is 1, R is 1. So this becomes 1 square. Okay, so this becomes F is equal to G. I think up to this it's clear. So we can say that the value of universal constant G, the value of universal constant G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. What is it? 6.67 into 10 to the power minus 7 Newton meter square per kg square. Another important point to be noted is that the gravitational constant G is numerically equal to the gravitational constant G is numerically equal to the force of gravitation. The gravitational constant G is numerically equal to the force of gravitation which exists between, this is B by W means between, this is exit, not exit मतलब एक exit होता है चले जाना बाहर, not that exit, exit मतलब जो होता है, so which exists between the two bodies, of unit mass kept at a distance of say 1 meter apart, है ना, kept at a distance of say 1 meter apart, from each other. So the gravitational constant G is numerically equal to the force of gravitation which exists between the two bodies or any two bodies of unit mass kept at a distance of say 1 meter apart. Therefore G is equal to 6.67 into 10 to the power minus 11 Newton meter square kg square. This is very important, which you need to learn, which you need to remember. This is very important. So by this what we can write, इससे हम क्या कह सकते हैं? ये जो कह रहा है the gravitational constant G is numerically equal to the force of gravitation which exists between any two bodies of unit mass kept at a distance of say 1 meter apart from each other. We can say that since this is a very extremely small value, this is a very small value, ये क्या, ये बहुत ही छोटा वैल्यू है ना. Since this is a very small value, so what happens, since this is an extremely small value, the gravitational constant G tells us that the force of gravitation between any two bodies will be very weak. It tells us that the force of, suppose this is the two bodies, so the force of gravitation between these two bodies will be very weak. Why? Because this G is very weak, है ना, because this value of G is very 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 small. The value of G is very 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 small. So I will write it here. The very small gravitational constant, that is G, the very small gravitational constant G tells us about the force of attraction or the force of gravitation, the force of gravitation between, B by W is between, in short I am writing, any two bodies, between any two bodies will be very weak, है ना. This very small value or extremely small value, very small value, extremely small value of the gravitational constant G tells us that the force of gravitation between any two objects will be very 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 small, negligible, and hence it is said that when two bodies attract each other, you cannot see both the bodies moving towards each other because the value of gravitational constant G is very small. It becomes very difficult and almost it's not possible to our naked eyes, है ना, to see that there is a movement of the body towards each other, since the value of this gravitational constant G is very 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 small. Okay, so next we'll move on to the next question. I think this might be very much clear to you. I have told you in a very layman language. सीधी तरह से मैंने आपको बताया है, सिंपल तरीके से मैं आपको बताया. इसमें कुछ भी नहीं है, कुछ रॉकेट साइंस नहीं है. ये बहुत ही सिंपल सी बात है, बहुत ही छोटी सी बात है. आप इसको आराम से समझ सकते हैं इससे जो मैंने आपको बताया. अब हम लोग आगे बढ़ते हैं. Okay. Now next question is gravitational force a scalar or a vector quantity? Next question is gravitational force a scalar or a vector क्वांटिटी? आपको मैं बताया था व्हाट डू यू मीन बाय स्केलर, विच हैज ओनली मैग्नीट्यूड बट नो डायरेक्शन. व्हाट डू यू मीन बाय वेक्टर, विच हैज बोथ मैग्नीट्यूड as well as direction. So what is the meaning of magnitude here? I already told you in the first chapter which I have taught, the motion. Magnitude means it's the force or it's the mass of the body. It's everything related to the body. So that is the magnitude. And direction, you are all aware about direction, the senses, the direction senses. So is gravitational force a scalar or a vector quantity? What do you say? The answer is gravitational force is a vector quantity. Gravitational force is a vector quantity. It means that it has both magnitude as well as the direction. It has both the magnitude as well as the direction. के पास दोनों ही होता है. It has both the magnitude as well as the direction. So I think this might be very much clear to you. It's simple. There's nothing great rocket science in this. Okay. So next we'll move on. Next question. Prove that the force of gravitation between two bodies. Prove that the force of gravitation between two bodies. Prove that the force of gravitation between two bodies is very small. How will you prove that the force of gravitation between two bodies is very small? We will see to it. Let the mass of body m1 be equal to 1 kg. Let the mass of body m1 be equal to 1 kg. Let the mass of body m2 also will be equal to 1 kg. Let the mass of body m1 be equal to 1 kg. Let the mass of body m2 be equal to 1 kg. And let the distance between them be equal to 1 meter apart. And let they be 1 meter apart. We also know that G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Just now we have studied, we also know that G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Therefore, using the formula F is equal to G into M1 into M2 divided by R square. F is equal to G into M1 into M2 divided by R square. Therefore, F is equal to 6.67 into 10 to the power minus 11 into 1 divided by R square. 1 into 1, that's nothing but R square. I have split this, you can write R square as R into R. Is the same thing. So 1 into 1. I think up to this it might be very much clear to you all. Prove that the force of gravitation between two bodies is very small. Let the mass of the body be 1 kg. Let the mass of the body m2 be 1 kg. Let the distance between them be 1 meter. So, and let the distance between them be 1 meter. We also know that G is nothing but, this is the value of G. So, using the formula F is equal to G into M1 into M2 divided by R square. F is this much. So, what happens now? So, F becomes 1 into 1 everything. 6.67 into 10 to the power minus 11 Newton. Okay, Newton. Force becomes Newton. Okay, 6.67 into 10 to the power minus 11. Even the force of attraction is very much negligible. It only says that even the force of attraction is very much negligible. So I think up to here there might not be any problem to you all. So we move on to the next topic. So this states that, okay, so this states that, I love this. So this only states that, so it states that, what does it state? That though the various objects though the various objects on the earth attract every other object constantly, but they do not cause any motion among each other. Though every object in this universe attract every other object, every object in this universe attract every other object, है ना, but constantly, but they do not create any motion, they do not cause any motion. Why? Because the gravitational force of attraction between them is very small. Because the gravitational force of attraction between them is very small. That is, though every object on this universe, in this universe, attract every other object, body, whatever you can, though every object in this universe attract every other object constantly, but they do not create any motion. They do not create or they do not cause any motion. Why? Due to the gravitational force of attraction between the body being very small. Due to the gravitational force of attraction. B by W is between, I am always telling you, I write it as shortcut. So, due to the gravitational force of attraction between them is very, very, very small. Is very, very, very small. Okay? So, I think this might be very much clear to you. Though every object in this universe attract every other object constantly, but they do not create any motion due to the gravitational force of attraction between them is very, very, very small, or you can write extremely small. Extremely small. Okay? So till date, I think this chapter is very much clear to you. You might not be facing any problem in this. It's not a tough chapter if you try to correlate this with the real world. But if you try to mug up this chapter and try to by heart this will become very much difficult for you. It will become a headache for you. That how can I go about it? It's becoming difficult and difficult for me day by day as I am going through the chapter, as I am going forward through the chapters. It's becoming difficult and difficult for me day by day. So basically you need to understand the chapter. Why is it happening? Simple. Why is this happening? Why any two objects in the universe are attracting each other constantly but they do not appear to attract? Why is this happening? So this is science. This is nothing like any religion. किसी ने कुछ कहा कई साल पहले, कोई गुरु कहते कुछ चले गए, उसका कोई तथ्य नहीं है, कोई मतलब नहीं है, हम आज तक उसको लेके चले आ रहे हैं, बाबा जी ने ऐसा कहा है, बाबा जी ने ऐसा कहा है. तो आप कपिल शर्मा का शो देखते हैं तो बाबा जी का क्या है, वही बात है. बेसिकली यू नीड टू गो about with the science. Whatever the science has given, it has all the proven facts with it. So I think it will not be very much difficult for you to go through it and to learn about it. So again, I would like to tell every students of our school and all the students worldwide, kindly be at home, be safe, take care of your family, of your parents, and also maintain cleanliness around you. Swachh Bharat, also maintain cleanliness around you, because there are many diseases which also happen due to untidiness, which happens in and around you. So thank you to all the students for listening to me very patiently. Thank you so much. So we'll be meeting very soon and we'll be covering the next portion of this chapter. This is a very interesting chapter, and those who are planning to take science in their higher studies, it's very much important to them. And at last, I would only like to say that be at home, be safe, stay safe, and use all the precautions that are required in this pandemic. Thank you so much. Stay blessed.